Bismillahirrahmanirrahim. Welcome back to my channel. This is going to be one of those interesting video where I'm experimenting with different type of flow graphs in GNU Radio. And in this video, I have in GNU Radio Companion, I have two different flow graphs. Using GNU Radio only, I'm gonna make me a transmitter using GNU Radio, and also I'm gonna make me a narrowband FM receiver in GNU Radio. So the flow graph that you're looking at right now is actually a flow graph of a narrowband FM transmitter that uses the boxes which are available in GNU Radio, and we will be able to transmit this using Osmocom source or HackRF specifically, because I'm using my laptop is going to be connected. Let me just connect my HackRF and as a transmitter, and then I'm going to use RTL-SDR dongle as a receiver. I think in previous videos I have made a flow graph where I have made a transmitter individually and I have used GQRX as a receiver, or either or. This is basically what have I done in previous videos. I have never made a complete transmitter and receiver, working complete transmitter and receiver using GNU Radio only. So this is basically a step towards making a fully FM system or a fully transmitter and receiver or transceiver system using GNU Radio only. And of course, you're going to do that using HackRF and RTL-SDR dongle. You can either use USRP or a full duplex device to achieve this, but I'm using HackRF as a transmitter and this as a receiver, RTLSDR as a receiver. The reason I'm not using Pluto SDR because I haven't updated my firmware, so my cap is at 325 megahertz, and from 325 all the way up to 3.8 gigahertz, that's why. So let me just simply walk you through. I have downloaded this a 2 meg file. I'm going to play this file for you so you'll be able to see what you expect to hear when I'm transmitting it. It's just some music file, wave file. This is going into a bandpass filter. So I am explaining you the transmitter first. So bandpass filter right here. Of course, you have some type of a low frequency that you're going to reject, and you're going to have high frequency that you're going to pass. So it's going to have a bell-shaped type of a curve. Anything under this bell shape, you're going to pass those frequencies. So starting 200, anything less than 200 frequency, I'm not interested in. Anything above than 3 kilohertz, I'm not interested, with a transition bandwidth of 500 hertz. Then I'm using a built-in FM transmit that has an audio rate of 44.1K. You can just select this to be 48K. That's perfectly fine. It works. I have tried both values. It works perfectly fine. Then it's going into a low-pass filter. I have chosen a low-pass filter of 44K. Why? Because when you sample audio, you sample at around this particular, it's 4 kilohertz, and when you sample it twice as frequencies at 8 kilo samples. So 4 kilohertz is, it's good for audio and things like that. After that, this is going into a rational resampler. What rational resampler is doing, interpolating your sample rate. So your sample rate is going to be interpolated by 100, which means sample rate times 44.1K multiplied by 100. And it's going to decimate this by 1. So now you have a new sample rate of 44.41 mega samples. Because your previous sample was 44.1K, now you times it by 100. This will give you a new sample rate. I've been telling you in every single one of my videos that GNU Radio does not keep track of your sample rate. This is what I've learned. And so you have to remember this. So by interpolating it, basically you're multiplying whatever the samples coming out by 100. So this is going to be 4.41 mega samples. And after this, you're visualizing this signal using your frequency sync and waterfall graph and Osmocom sync. The reason I'm using Osmocom, I can have my device argument to be HackRF, so which means I'm using HackRF as a transmitter, and the frequency and everything else is being controlled, or RF gain is being controlled by these GUI sliders. This is how that simple this flow graph is. The difference between narrowband FM and wideband FM is because your Bessel function, your index is 1. When you have your index 1, according to Bessel function, you might be producing, I think, 1 FC and then I think 2 sets of FC plus FMs and FC plus 2 FMs, and same thing on the negative side. Now let's look at my NBM receiver. So of course my receiver is going to be based on my RTL-SDR source. This is going into a rational resampler. Whatever the sample rate is coming in, which is 2.4 mega samples. This is the maximum allowed sample for your RTL-SDR dongle. I'm decimating it by 75K. So now when you divide 2.4 megahertz by 75K, your new sample rate is going to be 32K. And here's the part of what I was saying earlier. Remember, the low pass filter has a cutoff frequency of 4K. Now when you start sampling your frequency twice of that, now this is going to be 8 kilo samples, and this is what we generally do in telephone lines as well. That's why you sound different on phone than in your real, when you're speaking real in like not on the phone. So this is going into a low pass filter. That's why I have set this to 8 kilo samples or 8 kilohertz of cutoff frequency. Then is going into a narrowband FM receiver, which is also a built-in receiver. That is built in. Everything is exactly the same thing. I have chosen this to be 32K, even though the audio sync that I'm using 32K, 44.1K, 48 kilohertz. Everything is same. I think in previous videos I have used a quadrature rate as well as to be 192K, because when you divide this, you are getting a sample rate of about 48K. It doesn't matter. It doesn't make a huge difference. This multiply constant block right here, this is acting as an audio gain, basically an amplification factor. Whatever the samples are coming out, I'm going to multiply this, and this is being controlled by a GUI slider, which is known as RF gain. Or volume, you can call it, and then you can visualize this either on your GUI time sync and either on your GUI frequency sync. So let me move this over here on my flow graph right here. So that's the idea behind this, and this is easy. So in this tutorial, basically I'm making a complete transmitter and a receiver only using GNU Radio. Sometime I was using GNU Radio to receive signals, sometime I was using GQRX for reception, or sometime I was using GQRX for reception and GNU Radio for transmission. But this is a complete video that helps you design, help you learn how to transmit narrowband FM and then narrowband FM receive as well using GNU Radio. And the way the signal is modeled, the way our transmitter is working, this is according to the FM standard, which means I can receive the same signal on your cell phone device, or if you have an FM radio laying around somewhere, you can also open that up and then start transmitting it. So I have chosen an entire band from 88 megahertz all the way up to 108 megahertz with a step size of 100 kilohertz, even though the gap is around 20 or something, but I have chosen this to be around 100K. Now let's ready to transmit this signal. So let me hit my transmitter. Let me lower this. Let me turn on my transmitter first, which is going to transmit this using HackRF. So it's going to take this HackRF, as you all can see this from here. So it's going to start transmitting it. You cannot hear anything, but let me turn on my receiver. So it's going to start transmitting at 95.4 megahertz, sorry. And let me just turn this and turn on my receiver. And receiver, now focus here. The receiver start going to receive on 50 power RTL-SDR as well. So right here. So it's transmitting at 95.4. As you all can see this, 95.4. But I'm tuned in on my receiving side at 95.3. So let me just move this, and you can hear that tone that I'm transmitting it. So let me bring my mic closer, and y'all can hear this. So this is what you expect to see. Let me increase my gain as well. I hope you guys can hear this. So this is what is being transmitted.
Now, if I were to just turn off my transmitter, you won't be able to hear it on that frequency. So let me just turn off my transmitter. So this is my transmitter flow graph. You guys are hearing that music. So let me just turn this off, and then you won't be able to hear anything. It's just nothing but garbage. So basically that's the idea. Alright, so that's the idea. If you guys have any questions, just leave it in the comment section. Please don't forget to like and subscribe to my channel, and thanks for watching.